Hello and welcome back. In the previous video, we talked about the components of an interest rate. If you haven't seen the previous video, please see it first. In this video, we'll talk about the impact of frequency of compounding on effective annual rate. Compound interest, as you should know by now, is the interest on interest. That is, the money that we earn on our interest from the previous period. Let's take a simple example. Example 1. Suppose you have $1,000 to invest and you want to invest it for 2 years. You have two options. The first option is to invest it on simple interest and you earn fixed interest every period. Let's say the rate of interest is 10%. So the simple interest for 1 year will be 10% of $1,000, that is $100. So over 2 years you will earn a total of $200. This should be pretty simple. Option 2 is to invest it on compound interest and you earn progressively increasing interest as you are earning interest on interest now. Let's say that the interest is compounded annually. So after 1 year, you will earn $100 on your investment and at the end of 1 year, your new principal is $1,100. So at the end of second year, you earn $100 on your initial investment and $10, which is 10% of $100, on the interest you earned after first year. So after 2 years, you earn a total of $210. Again, this should be pretty simple. Let's see this again. We know that FV is PV multiplied by 1 plus I by Y to the power n, where PV is used for present value or current value or value at time 0. FV is used for future value or value at time t. N signifies the number of compounding periods and I by Y is used for interest rate per compounding period. If this is new to you, please see the video Introduction to Time Value of Money Calculations for CFA Level 1. Using this formula, at the end of first year, FV or future value will be 1000 multiplied by 1.1, which is $1,100, and FV at the end of second year will be 1000 multiplied by 1.21, which is $1,210. You need to get comfortable doing these calculations and you should be able to do these on BA2 Plus calculator. Let's try and see how we can do it on a BA2 Plus calculator. We will enter PV or present value as a negative 1000, negative as this is a cash outflow, you are investing money. I by Y as 10, which is the rate of interest per compounding period. You do not need to change it to decimal. N as 2, which is number of compounding periods. PMT as 0. PMT stands for regular payments, which is not present in this case. And then we'll press compute future value to get the answer as $1,210. Now let's take another example. Example 2. Let's say you have $1,000 and you can invest it on either simple interest or compound interest compounded annually for 20 years. The rate of interest is 10%. What will be the value of your investment after 20 years? Again, this should be pretty simple. For simple interest, interest per year will be $1,000 multiplied by 0.1, which is $100. So in 20 years, we'll earn $100 multiplied by 20, which is $2,000. And the total amount after 20 years will be $1,000 from the principal money and $2,000 interest, which is $3,000. For compound interest, PV is minus 1000, N is 20, I by Y is 10, PMT is 0. We compute future value to get $6,727.50. So, as you can see, by investing on compound interest, you receive more than twice of what you would have received at simple interest. This is the power of compounding. Example 3. Let's say you have $1,000 to invest for 2 years. The frequency of compounding is semi-annually. What will be the value of the investment after 2 years? In this case, present value or PV is minus $1,000. I by Y is 5 because we're compounding semi-annually. N is 4. Again, the number of compounding periods will be 4 in 2 years. PMT is 0. And when we compute future value, we get the answer as $1,215.51. So, as you can see, we are earning more money than when we were compounding annually. Next, what happens if we start compounding quarterly? In this case, present value stays as minus $1,000. I by Y will be 2.5 as now we have 4 quarters per year. N will be 8 for the same reason. PMT is 0 and we compute future value to get the answer as $1,218.40, which is higher than when we compounded semi-annually. Let's go a bit further. What if we started compounding monthly? So in this case, present value will be minus $1,000. I by Y will be 0.833 as now we have 12 months per year. N will be 24. PMT will be 0. And when we compute future value, we get the answer as $1,220.38. As you can see, the value of the investment is increasing as the frequency of compounding is increasing. This brings us to some very important conclusions. Number 1, both compound interest and simple interest values are exactly the same after the end of first compounding period. There is no difference at all. And this is because you have not started earning interest on interest. Number 2, higher the frequency of compounding, greater is the amount of interest earned. This is something that we saw in example 3. Point number 3, compound interest effects are more pronounced when the interest rates are high and the duration of investment is long. Please keep these very important conclusions in your mind as you work through time value of money problems. Now we can start talking about effective annual rate. Traditionally, all interest rates are quoted as annual interest rates and the frequency of compounding is mentioned. For example, you will see interest rate mentioned as 10% compounded quarterly rather than 2.5% per quarter. So, in reality, an investor will receive a different interest rate because of the effects of compounding. This actual interest rate received by an investor is called effective annual rate or EAR. Let's look at an example. Example 4. Let's say you want to invest $100 at 10% interest rate compounded annually. So you will receive 1.1 multiplied by 100 or $110 at the end of first year. What if the frequency of compounding was semi-annually? In this case, present value is minus 100, N is 2, I by Y is 5, PMT is 0, and when we compute future value, we get $110.25. So, as you are getting $110.25 for an investment of $100 after a year, the effective annual rate in this case is 10.25%. What if the frequency of compounding was quarterly? So in this case, present value is minus 100, N is 4, I by Y is 2.5, PMT is 0. We compute future value to get $110.38. So the effective annual rate in this case is 10.38%. In general, you can calculate effective annual rate using this formula. Effective annual rate is equal to 1 plus periodic rate whole to the power m minus 1, where m is the number of compounding periods in a year. So for our previous example, effective annual rate for semi-annual compounding will be 1 plus 0.05 whole to the power 2 minus 1, which comes out as 10.25%, and our effective annual rate for quarterly compounding will be 1 plus 0.025 whole to the power 4 minus 1, which comes out as 10.38%. I'll strongly recommend that you try these calculations on your own. As you must have realized by now, stated annual interest rate and EAR will be equal if and only if interest is being compounded annually. In all other cases, EAR will be higher than stated annual interest rate, and the difference between these two will increase with the increase in frequency of compounding. Finally, let's talk about the extreme case of continuous compounding. In case of continuous compounding, our effective annual rate formula is given by this equation. EAR is equal to e to the power r minus 1, where r is the stated annual interest rate. So, if r is equal to 10%, EAR for continuous compounding will be e to the power zero point 0.1 minus 1, which comes out to be 10.51%. Before we end this topic, let's see a couple of examples. Example 5. You are an investor who has been provided with two similar investment options with the same risk level. The first investment option is offering you 10.4% interest rate compounded semi-annually, while the second investment is offering you 10% interest rate compounded monthly. Which is a better investment option considering all other factors are same for these two investments? To solve these problems, it is imperative that we convert all the interest rates to EARs so that we can do a proper comparison. In our current example, for semi-annual compounding, effective annual rate will be 1 plus 0.104 divided by 2 whole to the power 2 minus 1, which comes out as 10.67%. I'll strongly recommend that you do this calculation on your own. For monthly compounding, effective annual rate will be 1 plus 0.10 divided by 12 whole to the power 12 minus 1, which comes out to be 10.47%. As we can see, the first investment option with semi-annual compounding is better in this case. So this is an example where you can use EAR to compare which one is a better investment option. Example 6. You are told that the EAR for an investment is 12.55% with quarterly compounding. Find the periodic rate for this investment. Now, in this question, you are given EAR and you have been asked to find out periodic rate. We know that EAR is 1 plus periodic rate whole to the power m minus 1. So in this case, 0.1255 will be equal to 1 plus periodic rate whole to the power 4 minus 1. When we simplify this further, we find that 1 plus periodic rate is 1.0299, which means periodic rate is 0.0299, which is approximately 0.03 or 3%. So, the stated annual rate in this case would have been 12%. By now, you should be comfortable handling effective annual rates, stated annual rate, and periodic rates. This brings us to the end of Learning Outcome C for this reading. In the next video, we'll talk about Learning Outcome D, solving time value of money problems for different frequencies of compounding. If you like this video, please do not forget to hit like and subscribe for more. You can also visit our blog at the link shown.